Good morning, everyone. Today we are going to use quantitative observations to determine how long it would take us to travel from the high school in New Jersey all the way to San Diego, California by walking. In order to solve this question, we are going to use a problem-solving method called Guppes. The first thing you need to do for Guppes is identify your problem statement. What you're looking at right now is your submission document. Everything that's in red are things that you need to eventually replace with your own words. So the first thing we need to do is, again, identify the problem. What are we trying to determine? So I'm going to delete this and replace it with some of our own words. So again, our problem statement is, how long would it take to walk? That's one of the catches. From the high school to San Diego. All right, so the first part of Guppes is G, our givens. What things do we already know? What things were provided to us? If you return to the Canvas page where the activity is listed, it gives you some of the things we already know, which include the distance from San Diego to the high school. So again, replace the red with your own words. And again, we know San Diego to the high school is a distance of 2,737 miles. Okay, something else that we know is that we're going to have to determine how long we sleep for, because that's something that's sort of a given, even though it wasn't explicitly stated in our problem statement, because we can't walk straight from San Diego to the high school without sleeping, right? So I'm going to imagine that I'm going to be adding 8 hours of sleep per night of my trip. So once I figure out the time it's going to take me, if I were able to walk straight through, I can break it up into days and add those 8 hours for each day. Next, unknowns. What do we need to know? What are we actually looking for? Again, I'm going to delete the red because this is what you're going to fill in. And I'm going to replace it with the things that I don't know. So first of all, I don't know how long it's going to take. The time. T stands for time. I also don't know, well, if I was running, I'd be going a lot faster than if I was walking. So how fast I go is kind of important. In other words, I need to know my speed. The next part of Guppes is to check for proper units. In physics class, we use 3 standard units to derive all other measurements. They include meters for length, time is measured in seconds, and mass is always measured in kilograms. If you need more assistance with this, you can view the other PlayPosit videos that discuss the purpose of units, as well as how to convert from one unit to the next. If it's not in those proper units, again, meters, seconds, or kilograms, you have to use this part of Guppes to do your conversion. So, if you look at our given information, we know that the distance is 2,737 miles. Miles is not the same as meters. So it's at this point that we're going to stop and figure out what is 2,737 miles in meters. So I'm going to erase this part of my submission doc. And now, because this is probably going to be a math problem, it's going to be difficult for you to type in Word docs. So here you might be able to do your work on paper and then take a picture of it and add it to this submission. Okay, so proper units. Again, we need to fix this to 2,737 miles and convert it into meters. So we're going from miles to meters. In order to do that, we need to know the conversion factor between miles and meters. And that's this. 1 mile is actually the same exact thing as going 1,609 meters. Again, this is called a conversion factor. That's because these two things measure the same distance, just in a different way. Sort of like we could say you have $1 or 4 quarters or 100 pennies. It's 3 different ways to say the same amount of money. So, how do we convert from one unit to the next? We use a method called the fence post method. In the fence post method, it kind of just looks like a fence post. So you start with something like this. Now you always begin with the number you're converting in the top left corner. In that case, this number is 2,737, and it's very important to include the units. So I actually need a little more space. I'm going to put MI for miles. On the second fence post, we're going to include our conversion factors. This original number is really just over 1, so we can just ignore that. But on the second fence post, we're going to opt to put either 1 mile or 1,609 meters on both the top and the bottom. So what is the goal here? Well, the goal is to get rid of the measurement in miles and make the measurement in meters. So to do that, I need my miles to cancel. Just like you would in math class have 3 over 3 is really just equal to 1. They cancel out. I want to cancel out my miles. So I'm going to put my conversion factor of 1 mile on the bottom so that they will cancel. On the top of my fence post, I'm going to put 1,609 meters. Okay, so what do we do from here? Now you're just going to multiply across the top and divide by the bottom. So we'll put a little multiplication symbol and our equal sign, and we'll see that our miles cancels, and we're going to have to take 2,737 times 1,609 meters. Grab my calculator. And our final answer is a total distance of 4,403,833 meters. That's a lot of meters. But think about it. A meter is really only this big, whereas a mile I can't fit in this classroom right now. So you're going to have to cover a lot more meters to travel the same distance in miles. There's some other things that we're going to have to convert. If you look in my gibbons, I said, I know I'm probably going to sleep for 8 hours a night, but I told you that the time had to be measured in seconds. So we might have to go back and figure out how many seconds that is. So let's see. I need to convert 8 hours per night to how many seconds I sleep per night. So I'm going to erase this conversion. I'm going to leave this number to the side because this is very important. So my distance is really 4,403,833 meters. Now I'm going to start fresh. So again, to do a conversion, we're going to start with our fence post. We also need to decide what we're converting. So we're starting with hours, and we need to go to seconds. So to get from hours to seconds, it's kind of a big jump, but we could go from hours to minutes, and then minutes to seconds. Excuse my sneezes. So what are these conversion factors? Well, we know in 1 hour, there are 60 minutes, and in 1 minute, there are 60 seconds. So let's let's start with our fence post. Top left corner, I put the number I would like to convert. So here I would put 8 hours. And again, my goal is to get rid of the unit hours. So I need to put my conversion factor for hours in a place that will cancel out. So I'm going to place the 1 hour on the bottom, 1 hour. And in 1 hour, it's the same thing as 60 minutes. I'm going to do the same thing because the hours cancels, that's great. But now I'm left with minutes, and that's quite not what we want. We want to get all the way to seconds. So let's do one more step. In 1 minute, there are also 60 seconds. So now we're ready to multiply across the top and divide by the bottom. Because you can see here, our minutes also cancel, and all we're left with are seconds. So that's what we want. So 8 times 60 times 60, handy dandy calculator. 8 times 60 times 60 equals 28,800 seconds. So I'm going to need to include that in my final answer. All right, moving on. The next part of Guppes is the picture/principle. So again, we did the G, U, proper units. Now we're doing picture and principle. What is our strategy here? How are we going to solve this question? So here, you're going to tell me, how are you going to determine how long it will take you? So how can I visualize the problem? What approach will I take to solve it? Well, if we go back to our givens and unknowns, I know how far I have to travel. I know I need to add in a time for the amount of time I spend sleeping. But I know that I need to find time total for my travels, as well as how fast am I moving. So how could I determine how fast I'm moving? Well, there are a couple ways, especially since you have your physics equipment in the classroom. The easiest way would be to select a set distance, and you can decide this with your partner in the classroom, but select a set distance. Maybe it's 2 meters. And use a stopwatch to figure out how long does it take you to travel 2 meters. At this point, you're probably going to stop the video and actually complete this test. Through a lab investigation, I figured out that I walked 2 meters I walked 2 meters in 1.5 seconds. So the question is, how fast am I walking? How can I figure that out based on the distance I traveled and the time it took me to travel? So let's think about speed for a second. When you're driving on the highway or walking to school, you might pass signs that say 65 miles per hour or 25 miles per hour. And what does that mean? 25 miles per hour. When we use the word per in math class, that really means division. So this means that I traveled 25 miles in 1 hour. In this case, I can see that a speed is really a distance divided by a time. Well, I have both of those things. I have a distance of 2 meters and a time of 1.5 seconds. So in order to calculate my speed, I'm going to do a distance over time. The distance I traveled was 2 meters. The time it took me to travel that far was 1.5 seconds. And that gives me a speed of 1.33 meters per second. So if we go back up to my unknowns, I don't know time, and I also don't know how fast I walk. Well, now I do. So we can go back and say, all right, well, if I know how fast I was walking, I could determine the time it would take me to travel that whole distance of 4,403,833 meters if I'm going at this rate. Okay, so what mathematical equations do I need to solve the problem? Well, in order to determine how fast I was going, I had to use this equation that I developed saying that speed is equal to distance over time. So right here in this spot of Guppes, I'm going to list that equation. So what mathematical equation do I need to solve the problem? Well, I need to know speed equals distance over time. Now, I'm ultimately looking for the time it's going to take, right? Sometimes I like to put a little star to let me know which variable, or the thing that I can change, is the one I'm solving for. So I put a little star next to the t because that's what we're looking for. And then the last step of Guppes is to actually solve. So for me, how long did it take me to cross the country walking at that speed? Well, again, I'm using this equation, s equals d over t. I know my speed is 1.33 meters per second. I know the distance I have to travel is 4,403,833 meters, and I am looking for the time. So that one will remain as a variable. Remember, that's why I started, so I could remember that this one's not going to have a number. That's what I'm trying to solve for. Now in math class, how would I solve for this t? Well, right now it's in the denominator, so the first thing I need to do is get rid of it. So I'm going to multiply both sides by t, so the t's cancel. So then I end up with 1.33t equals 4,403,833 meters. And now you can see I can easily just divide by 1.33 to get my time, and let's figure out what that was. And so the time in seconds that it would take me to cross the country is 3,311,152.6 seconds. Keep in mind though, this is if I walk straight through. So the next step, we would have to include all those times that I stopped to take some rest. I'm going to let you finish this one on your own. Make sure that you go back and you consider how much time you spent sleeping, about 8 hours, and consider that in seconds, or convert this back to hours to see how many days is 3,311,152.6 seconds. How many days would that actually be? So for each day, I would need to add 8 hours worth of time. Once you're done, submit to Canvas. Make sure to include any pictures of work that you may not have been able to type up in your doc. Thank you.